Hello, this is Mr. Abbott again, and I'd like to help you work through this worksheet on season statements. If you look at the top, it gives you a diagram of the orbit of the Earth with the Earth at 4 positions, and it lists the seasons, and this is the dates for the Northern Hemisphere. You have to memorize these. So, starting from the top, the winter solstice is 12:21. Vernal equinox is the spring equinox. That's 3:21. Summer solstice is 6:21. And the autumnal equinox or the fall equinox is 9:23. Now, on the picture, summer and winter are almost always directly across the center. This is definitely not to scale. You can't really see the distances, and you never judge it on distance. You have to look at the North Pole. At this position, the North Pole is tilted away from the sun. Over here, the North Pole is inclined or tilted 23.5 degrees from the sun. So this would be winter in the Northern Hemisphere, which would be position A, and this would be summer. We know that we're orbiting counterclockwise. So starting from winter, you'd go spring. So that's B, summer, and then this position is fall. Now, each seasonal date is really described by the location of the vertical ray. The vertical ray is where the sun is hitting directly or at a 90-degree angle. So statement 1 says the sun's vertical ray is on the Tropic of Cancer. Now, the Tropic of Cancer is 23.5 degrees north. I'd like to make another little model over here, and we're going to name it vertical ray. So draw a circle, and each season the vertical ray is either on the equator, the Tropic of Cancer, or the Tropic of Capricorn. So the vertical ray migrates between 23.5 degrees north and 23.5 degrees south. And you basically have to memorize the position of the vertical ray. Now, on 6/21, it's our summer solstice. So the vertical ray is closest to New York. It's on the Tropic of Cancer. On 12/21, when we see the sun at the lowest angle, the vertical ray is farthest from us, so it would be at 23.5 degrees south. Now, 3/21 is an equinox, and that's when the vertical ray hits the equator. It hits it going north for spring, and then it hits the equator. The vertical ray crosses into the southern hemisphere on 9/23. So I'm going to just draw an arrow. For 6 months, the vertical ray moves north, and then for 6 months, the vertical ray appears to be moving south. So the vertical ray is on the Tropic of Cancer is summer, and summer from this list would be C. Days and nights are equal. Okay, the word equinox means equal night. So this is going to be 2 of these. Okay, equal night has to be the equinoxes, which is B and D. A 6-month period of darkness begins at the North Pole. Okay, once the vertical ray crosses into the southern hemisphere, the illumination only moves 90 degrees up or 90 degrees down from the vertical ray. So once the vertical ray drops into the southern hemisphere, the sun is going to set at the North Pole. So this is actually going to be the autumnal equinox. This is one of the more difficult ones. That's D. Earth is at its closest position. Now, the exact point is called perihelion, and that's around January 3rd. But the season when we're actually closest is our winter, So this is going to be A. Winter begins in Australia, which is in the southern hemisphere. The seasons in the southern hemisphere are opposite. When we're getting more insolation, they're getting less. When they're getting more, we're getting less. So their winter is our summer. So this is going to be position C. All right. The vertical ray reaches the equator. It has to be an equinox. But the vertical ray is moving north, which means our days are getting longer and the sun is getting higher. If the vertical ray hits the equator going north, it's going to be the spring equinox. So that one's going to be B. Tropic of Capricorn is 23.5 degrees south. Okay, that's going to be our shortest day of the year with the sun at the lowest angle for New York. So that's going to be our winter solstice. So 7 is A. The southern hemisphere is pointed towards the sun. Well, when the hemisphere is pointed towards the sun, that's going to be summer. The inclination of the axis is 23.5 degrees. So when the southern hemisphere is pointed towards the sun, the northern hemisphere is pointed away. That means it's going to be our winter, which means 8 is also A. The period of daylight varies from 12 hours at the equator. Well, the period is always 12 hours at the equator. The equator is always half in light and half in dark. But 24 hours at the South Pole, that's going to definitely occur on our winter solstice. So this one should definitely be for the winter solstice. 9 is position A as well. Now, the sun appears to stop. The term solstice literally means sun stop. So if I slide this up a little bit, solstice, term solstice means sun stop, and the sun is going to stop twice. It stops once on 6/21 because it moves north for 6 months and then it stops. It moves south for 6 months and then it stops. The sun reaches its highest angle on the solstice and then it stops, or it hits its lowest angle in New York on the winter solstice and then it stops going down. Now, it's a solstice. The sun appears to stop before beginning its southward motion towards the equator. That means it's got to be on June 21st and start to move down. So this is our summer, and that's going to be position C. All right. For each season, you also need to know the direction of sunrise and sunset. Now, there's a really easy trick for this. You know the equinox is due east and due west. All right, the only days when sunrise is due east and sunset is due west is an equinox. Okay, if I write the word June, I'm going to capitalize the last 2 letters of June. For the summer solstice in June, sunrise is north of east and sunset is north of west. Okay, but this one says the sunrise occurs due east and due west. That is going to be your equinoxes, which is B and D. 15 hours of day and 9 hours of night is our summer. Summer from these letters is C. The vertical ray hits the equator, which means it's an equinox. But now the vertical ray is moving south, which means the vertical ray is going to head into the southern hemisphere, which means it's got to be the autumnal equinox. So that one has to be D. All right, for 14, sunrise occurs farthest north of east. I already showed you the trick. From north of east, it's June, so that's our summer when we get the longest, highest path in New York State. So summer out of those letters is going to be C. Sun has reached the highest altitude at noon. So you're talking about summer, but it's summer in the southern hemisphere, which means it's winter for us in New York State, which means we are going to be at position A. 16. Okay, the position of the sun determines the length and the direction of the shadow. If you imagine a vertical post, okay, if the sun is lower in the sky, you get a longer shadow. So a low angle gives you a longer shadow. As the sun rises, and from our perspective moves across the southern horizon, if you get a higher angle, the length of your shadow gets shorter. You should know that the noon shadow is the shortest shadow for the day. So at solar noon, the sun casts its shortest shadow. Now, the observer's shadow will be the longest. Okay, that means you have the lowest angle. And the sun is lower in the sky in the winter. So that should definitely be A. 17, the altitude is farthest south of east. Well, if you want to have a little bit of a misspelling, if you can remember, June is north of east, and you slightly misspell December, December is going to be south of east. So south of east to south of west is the winter solstice, which is going to be A. The altitude of the sun reaches a minimum. Means the sun is at the lowest angle, which means it's winter. So winter for observers north of the Tropic of Cancer, which would be 23.5 degrees north. Our winter is December 21st, which is also going to be position A. 19, the length of the shadow is shortest at noon for an observer south of the Tropic of Capricorn. A shorter shadow means a higher angle. Okay, a higher angle means it's warmer, you're getting more insolation. So this is asking for summer in the southern hemisphere. Okay, summer in the southern hemisphere is our winter, so this one is also going to be A. 20, the Earth is traveling slowest. Well, the Earth travels slowest when it's farthest away. You can remember A is away, so the name for that point in the orbit is actually called aphelion, and that's usually around July 4th. So we're actually farther from the sun and traveling slowest in our summer because the seasons are based on the tilt. They have nothing to do with the distance. So for this one, the best answer for number 20 should be the summer solstice, which is choice C. Now, the only thing I'd like you to do on these diagrams in the bottom, you have to be able to look at the terminator and the location of the vertical ray and determine the seasonal date. Now, for all three of these, the one directly in the middle that I'm highlighting, if they give you an odd number, it's the one in the middle. But right in the middle, where the sun is hitting directly, you're going to see that it's hitting perpendicular or making a 90-degree angle. I'm going to label each of those the vertical ray. Now, when you look at the first one, the vertical ray is hitting the equator. The north and south pole are on the terminator. So this has to be an equinox. So this is 321 or 923. In this diagram, the vertical ray is hitting north of the equator. For this one, the vertical ray would be hitting 23.5 degrees north. So this would be our summer solstice. So the date for this would be 6/21. The entire Arctic Circle, the top 23.5 degrees would be in light, and the bottom 23.5 degrees would be in darkness. So you'd go from 24 to 12 to 0 hours. Now, for this one, the vertical ray is striking the Tropic of Capricorn, which means it's our winter solstice. Okay, what's the date for our winter solstice? That has to be 12/21. Now, that means the entire Arctic Circle would be getting 0 hours of day-night. You're tilting 23.5 degrees into the darkness, so the top 23 is completely dark, and the bottom 23, the Antarctic Circle, would be completely light. I hope this video clarifies and helps you with these diagrams. The only other one I can think that you have to add would be the celestial sphere model with the path of the sun. But hopefully this is helping you to understand the changes that happen on our planet during the seasons. Take care.